kind of an anachronism in a way. There's a lot of things that you'll see in my presentation that that from a modern programmer's perspective make you go, huh?
Mm,
But there was good reason why they did these sort of things. Um, but there's no need for them now, so that's why they've been removed or deprecated.
okay. What made you want to start looking into it?
Incidentally, it was because I found out that my TI-99 has somebody wrote a Fortran compiler for it, and it's the only real. Um, Let me repeat that. The TI-99 has a Fortran compiler that somebody wrote for it, and it's really the only good high level language for it. Like they
Oh,
have
okay.
a special C compiler called C99,
Yeah.
not C99, the standard C99, but C as in C99 from TI-99, and it's like a really stripped down version of C.
Oh, geez. Okay.
Yeah. Whereas the TI-99's Fortran compiler is actually uh, a subset of Fortran 77, but like I mentioned earlier, there's no standard library, so it doesn't actually affect anything. So it's a much smaller compiler
Okay. So rather than writing in BASIC, you're just like, well, Fortran's a little bit
using
better.
Fortran. Yeah,
Can you
yeah.
use? Wait. Is there any object-oriented programming that you can do on the T99 with Fortran, or is this, or
No,
okay, I didn't think
because
so.
I'll explain why that is
Okay.
a little bit later. Hello, James. I'll explain a little
Hello.
bit later why you can't do object oriented programming on that.
That'll be cool.
Well, I mean, not not directly, but it'll become apparent why it is.
Okay.
Uh, because I'm going to be going through the different standards, starting with the first. All right, so I'm ready when you are.
Okay.
So let me know when you started recording.
I started recording. Go ahead.
Okay, so can you see my screen, everybody?
Yeah. What the? Oh yeah.
So
Beautiful.
now this comes from, and I know that when we were talking before the recording, I said I would explain this before I showed it, but I got a little jumped the gun a little bit. Okay, so in Fortran, letters I, J, and K are integers unless implicit or explicitly typed. So letter, every other variable name that starts with any other letter but those I, J, K, I think N and M. Actually, I don't remember. It's not doesn't come up very much when you're actually using it. You'll see that in a bit. But so the joke is that the variable God is of real type unless you declare it an integer. So yeah,
That's
there's that.
weird.
Yeah.
So IJ and
Now
K. So wait a minute. So IJ and K are integers, and everything else is real.
yes. Now
Okay.
it yes, but I'll explain this a little later. But basically, it has to be typed. So like, say I wanted to declare an integer. I don't know, like name it awesome integer, right?
Mhm.
uh, I would have to type integer, awesome integer, for it to actually recognize it as an integer. Otherwise, it would say there's no type
Oh. Okay.
unless you don't use a certain statement. And I'll show you that statement that turns the implicit typing, is what it's called, off, which is basically what's going on here. So God is implicitly typed real. But that's getting a little ahead of myself. So I want to share a little bit of an excerpt from, I think, something pretty funny. It's a tongue-in-cheek essay written to, uh, I think, Datamation. Uh, it's called "Real Programmers Don't Use Pascal." Now, this is a play on an earlier article that said "Real men don't eat quiche," and let's see here. this is what I wanted to share. Real programmers aren't afraid to use go-to statements. Real programmers can write a 5-page long do loop without getting confused. Real programmers like arithmetic if statements. They make the code more interesting. Real programmers write self-modifying code, especially if they can save 20 nanoseconds in the middle of a tight loop.
I'm so scared.
What's happening?
Real programmers don't need comments. The code is obvious.
Kyle, there are freshmen in this channel right now.
And let's see here. There's another one I wanted to read. Real programmers don't comment their code. If it was hard to write, it should be hard to read. Yeah, so I figured I would cause you guys a little pain before I started. And so this comes in a time where there was that real shift in what the language everyone knew was coming from. And for a long time, people thought it was Pascal. It turned out to be C, but it, for a while, was thought to be Pascal. But Fortran never really went away. Do you know anybody who does Pascal or Lisp? Anyone?
Not really.
No.
My dad's first program he had to write for his graduate degree, he wrote it in Pascal. And he loves it just because he likes Blaise Pascal's writings.
Nice.
Which are
Fair
completely unrelated.
I guess
But
I mean, yeah. I think Adam wanted to write a program in Pascal because there's a way to like use the Raspberry Pi without an operating system, but the thing that you put on it requires you to program in Pascal. I don't quite remember. But yeah, not much.
I have dropped a link to this paper in the ACM chat if you guys are interested in looking at it later. It's actually pretty funny because it's a lot of it is it is a joke, right? So none of it's to be taken seriously. So now let's move on to the Fortran automatic coding system for the IBM 704. This is the Programmer's Reference Manual from October 15th, 1956. This was the first form of Fortran. And the creator of Fortran is quoted as saying he hated writing programs. So he wrote a program so he didn't have to write it anymore. And that was Fortran. And that is probably me misquoting him. But I said what I said. Now, as you can see, it's a 51-page document, which by standards of modern languages is tiny for a reference manual for a whole language. We're not going to go through it all, but let me show you this. So this is a punched card. And you notice that this is what they call a Fortran program. And if we look at this picture, can everyone see this?
The good old days.
Yep.
Now, I'll come back to this image when I talk about Fortran 77. But this is what Fortran was originally written on. And all programs, actually. I believe probably C was as well for a while. I'm not sure on that, though. Now, one of the big things about Fortran... Oh, I forgot to mention that key punching each statement is punched on a separate card. If a statement is too long to fit on one card, then it can be continued over as many as 9 cards. And that means that in this column, this one here that says continuation, I'm not sure if you can actually see that. I just know that this says continuation because I know the language. This is column 6. And if you were to type now, but you would punch that little hole there, it would mean that this is a continuation of the previous card. And over here is an identification number. So, and these are line numbers. This is the inside box is the actual program statement. All right. Now, let's look at constants, fixed point constants. any fixed point constant may be used as a statement number. So, right. Variables. Fixed point variables are distinguished by the fact that their first character is I, J, K, L, M, or N. And this goes back to what I was talking about. This is something called implicit typing. So the compiler just kind of assumes that anything that starts with any of these letters is an integer. Anything else is a real number, right? Okay, subscripted variables, which means like it has like this index here, right? Hey, wait a minute. Did you notice anything that we're missing in this section?
Some pictures would be nice.
Some what?
Some pictures would be nice.
Yes, Luke, but one big thing that we're missing here is any way to represent text.
No strings.
No
I don't-
characters.
No characters. Okay.
No strings, no characters. So that brings in Hollerith constants. Hollerith constants is an integer. These are an integer. Now, that brings me to my first code snippet, aptly named obsolete.f. Can everyone see my my screen?
Yep.
Yep. Yeah.
There it is. All right. So, this is a program that is written in Fortran, and boy, the mess does it look. So, right here, right? You see in this format statement right here, it says 5H write, right? What do you guys think that means? Any guesses?
Right, 5 H's, so like the letter H 5 times.
That's not a bad guess. Anyone else?
Right, 5 and hacks.
Also not a bad guess.
Yeah, just writing something to memory.
Now, let me show you what it actually does. Let's see, cd/sources/Fortran ACM talk, lowercase. Oh. Okay. Do you see what it says there?
Right?
It says right.
What?
This is the problem. This is why Fortran was changed. This is a Hollerith statement. This is what is called a Hollerith string. So, if you look here, notice the line number, 100, right? This statement corresponds to this format. So the general form of the write statement is write, the unit, which in this case is like the terminal, so it's 6, and 100, which is the format statement. So I wrote that in this format statement as a constant. So every time I call this, anywhere in the program, it's going to write write. Okay? Same thing with these, but these are all different words. Now, I want to bring up another... now you would think it's stupid. I can't really say how well it would be useful. Back then, even, I don't use this function. It's actually completely obsolete and removed. It's been removed. I think it was Fortran 95 was when it was removed. This is called the arithmetic if statement. You see this in this yellow block?
Yeah.
So what this is saying, now keep in mind that I'm reading in from the standard input, right? So 5 is standard input, 6 is standard output. So any group of characters, now this is actually just because I didn't want to write a format statement for this read, but this was added, I believe, in Fortran 77 into an integer I, right? If I minus 5, if what? If I minus 5. Does that make much sense?
Not.
Well,
well, I guess it's like if because like with some languages where you get a 0, it's false, and anything else is a true.
Yeah. So
you're
that
not you're not really wrong. It's much stupider though. Like it's not stupid, but it's just it's an anachronism. You know, it doesn't make sense in modern computing. So what this is saying, right? And I'll demonstrate this. Give me a number, just a number, any integer.
7.
Okay. 7. Okay. So let's go and find where positive is defined as a string, right? So that would be here at 400, right? So we got to find the right statement that corresponds there, right? So that means that because we put a number that's greater than 5, it sent us here to 30. What do you think would happen if I put in 5? Anyone want your guess?
My hope is that it jumps to line 20, writes the 6, it writes the 300, which is 0.
Yes.
So it should just output 0.
Yes, exactly.
The
Now,
heck?
there's a reason why I chose those as the strings to write, because it makes it a lot easier to understand. Basically, what this is if this happens, do this, this, or this. So 10 would be if the result is negative, go to 10. 20 would be if the result is 0, go to 20. And 30 would be if the result is greater than 0, go to 30, right? Okay. So that is what's called an arithmetic if statement, and nobody uses it anymore.
That's interesting.
Yes. So
is it just based on if the number is negative, positive, or 0?
Or 0.
Okay,
yes.
Got it. That's weird.
It is, and I thought it would be pretty interesting to bring up.
Yeah.
Now, one of the big things with Fortran in the early days was that there were no good standards of which flavor of Fortran you were using. There were so many different standards, but no unifying standard, like how there's different compilers for different languages. It doesn't mean that they're not interoperable. However, back then, it was to the point where they were the same language per se, but they were completely and wholly incompatible with one another. So if you had, say, Cray's compiler versus IBM's compiler, they wouldn't work together at all. Part of the reason being because of the fact that they use different character sets or encoding or whatever you can imagine. There were just things that made them not work together. And that was one of the biggest reasons why they created Fortran 66. Let me find, I had it open here. Fortran 66, this isn't it either. Well, anyway, Fortran 66 was the first attempt at standardizing a Fortran as a language like we know it today. It really did help a lot, and it spawned the more important Fortran 77. Now, Fortran 77 is the most commonly encountered form of the language, and I will pull up. Technically, this is in Fortran 77, but these were all not replaced, but done again in had it open in a different. They were replaced by different functions in Fortran 77. Now, this is in Fortran 77, and you notice that every line that's blue has a C in front of it. That's because it is seen as a comment by the compiler. And remember what I said about a card. It's one line of code, right? So each of those C's represents a card. Naturally, they wouldn't actually be printed on cards, but, you know. So for this format here, I wanted to call attention to this. You notice that I have an A there instead of an H. That means alphanumeric, because now I have characters.
Oh, they finally added that to the language.
Yes.
Okay.
Now, just take a guess at what this one does.
I don't know. I think it prints out "Hello, Sam."
Hello, world. Now, I want to call attention to something about this. That format statement is still there. That write statement is still there. That's rather unwieldy, don't you think?
Yeah.
And can you imagine formatting various things that are going to be printed out in one message? You'd have to use one format, but you'd have to string together a bunch of formatting, junk in order to get it to read properly. Because this is pretty low level stuff right here. This is like maybe 1 or 2 layers of abstraction away from the hardware. So it's not very high level stuff. Now, you notice that the everything other than the comments is in uppercase letters. This is because there were no lowercase letters in the character set for Fortran at the time. And as we can now pivot back to this Fortran card, I wanted to call attention to the lines and stuff. So you see the columns, like the statement number here, right? Continuation column, the statement columns, and this identification column. This would be where the labels go. So like on that one that we did with the Holleriths, it would have 100, etc. Right? And that would be your format statement. And that format part would go in here. And then this stuff is just extra. But you notice that right here at 72, from 7 to 72, right? Why? It just, you notice that I have 7 spaces before each thing, and that's because the compiler interprets that as the beginning of a program. Otherwise, it's going to be construed as a line number or a continuation column entry. So this is what's called fixed form source code, and it is ugly to say the least, and especially considering that by the time Fortran 90 came around, which was in 1990, nobody was using punched cards anymore. So all the way through the 80s and partially through the 90s, while Fortran 90 was still being, adopted, it was done with the same fixed form source code. And you'll see if you look at old programs for Fortran, they will always follow this format. There can be no more than 72 characters from 7 to 72 in your statement, right? So that's a little restricting, don't you think? Excuse me. Now I want to show you one more thing, and we're going to contrast. Oh, yeah, I got it open still. I forgot. We're going to contrast these two. This one's written in Fortran 90. Which one's better?
Jeez,
The one on the right.
90 works. It looks just totally different.
Yes,
Like
and it pretty much is, but you still have access to all of the same format and stuff like that. All of this is compiled with a Fortran 2008 compiler. So, I mean, it's pretty. The goal was, because of the large software base, is to make sure that your program still works. You know. Now, one of the biggest problems with the source code form on the left is that the fixed form really is limiting. So let me show you how you would do this, right? This is how you would write a continuation. Right?
So that continues it onto another card?
Yes.
Okay.
Now, with this, it's really just not so good. And with modern technology, there's no reason to be so rigid. And some of the other problems that led to the creation of Fortran 90 was that there was no dynamic storage, no pointers, nothing like that. There was also a lot of problems with creating any sort of data structures. All of that stuff was just not available to Fortran 77 and before. That changed beginning in Fortran 90. As you can see, this is called free-form sourcing. So, well, not sourcing, but free-form source code. It's much more friendly to the modern programmer, because you're not pretending like you're using a punched card anymore. So, another thing is that you see this word here, message. Technically speaking, this would be illegal in Fortran 77. Can anyone guess why? Anyone?
The lowercase e is illegal. Which part of it was illegal?
This whole statement here. So the name message. Does anyone have any idea why that would be illegal?
Does it have something to do with the fact that, like, how the beginning character is something and it would interpret that as something else? Like,
No, because notice I have character in front of it, so
Okay.
I have actually explicitly typed that.
Okay. I'm not sure then.
The reason is because your variable names can only be 6 letters long.
Of course.
Oh.
Why Why didn't I realize that one?
I didn't notice this when I wrote it, but that's because, like I said, this is a Fortran 2008 compiler, and you know, it doesn't care. Fortran 90, you can do up to 31 characters, but I struggle to fill 10, if that. Yeah, so that definitely did lead to the changes that were necessary for Fortran to be a practical language for modern computing. And indeed, it is still used for things like benchmarking supercomputers, because it is, rightfully so, it's known as a very fast executing language if done correctly. And that's a key, done correctly. Now, some of the biggest things that I will point out is that these comments, you can't do inline comments like this one in Fortran 77. This would be interpreted as a bug of some sort. They wouldn't know how to handle that. So this is also another thing that I put in there just to show you how comments look, right? It's just, it doesn't work with systems that we have now. That being said, knowing how to read Fortran 77 and specifically how to identify the weird stuff really does go a long way when you're actually using Fortran as a programming language. And with that, we can move on from the old stuff and move on to the new stuff. So let's move on from this one because it's pretty simple. This one is object-oriented programming in Fortran. Looks a little weird, I'll admit. So this is how you declare a variable, right? So this is the statement I was mentioning earlier, by the way, the implicit none. That means that every variable has to have a type. Otherwise, it'll say there's no implicit type. Or, yeah, it needs to be explicitly typed out that this is a real number, this is an integer, this is a circle, and so on. So before Fortran 90, there were absolutely no way that you could actually create any sort of object-oriented programming or anything like that. No types, nothing. So let's take a look at this and let's dissect it. So it starts with the word module. And down here, it starts with program. Every program and every module ends with an end module and then the name, or end program and then the name. And every routine, every function does the same thing. Now, you can think of modules as, in a way, similarly to a package in other languages. So with this module here, I'm using this to define a circle as a class, or in this case, a type, right? So type, comma, public, circle. Real, these dudes, by the way, that's like it's the assignment operator or something like that. They just put that in there next to separate the attributes from the variable name. So, and then it says contains, and this basically means exactly what it sounds like. It contains these procedures, which would be the methods of the circle class. So area and print, right? So then it has another end type circle, contains function circle area. And for those of you who have done any sort of object-oriented programming, it makes a little bit more sense than somebody who's completely new to programming in any real sense. So note that right here, this percent radius. So you know how like Java, C++, other languages like that have like this dot radius. In Fortran, it's the percent sign. So it means the same thing. And yeah, so basically it just does this. Now we have to go and create a program because the module itself is not executable. It's compilable, but not executable. And what I mean by that is that the compiler looks at the module and says, okay, this is part of another program, right? So it doesn't look at a module and think it's a program. So you can think of it like in Java where you need the main method in order for it to actually do anything. You need a program to run things. So the circle test use class circle, and that is the class circle module that we defined up here, implicit none, and I meant to, do explicit typing. So again, just to reiterate, that just means that you're not letting the compiler figure out what you want your variables to be. So this is how you declare and instantiate a new type or a class, right? So C is now a circle. Now C is circle with the radius of 1.5. And then we just call C's print method and it does that, right? So let's just go ahead and run this. I misspelled circle. There we go. So that's what our program has done. It's taken a circle of radius r and calculated its area. And that's Fortran object-oriented Fortran, right? Are there any questions about that so far?
See, I could get behind this one a little bit more. I like that one.
Yeah, so this is Fortran 90, and it was a big step. Now, mind you, that it's more of a relaxation of rules than it is a complete overhaul of the language. There obviously was added features, but it was much less like a new standard as it was a revision. So it's the same exact language, and it's just certain things were added, and they kind of made things a little bit more modernized.
Can you still use, like, if you wanted to essentially write a Fortran 77, would a Fortran 77 program run on a Fortran 90 compiler?
Yeah.
Okay, so you can just start writing using the old statements, the old code and everything, and it just works.
Yeah, you might get warnings.
Okay.
Like saying this is obsolete.
Okay, got it.
Again, it does also depend on the compiler and how old the code is.
Right.
Like if you're using like Fortran 66, I'm not sure if it's supported.
Okay.
It really depends. But in general, yes. Part of the reason why it has retained some of these weird parts of the language is exactly for that reason, so that as technology increases, they can continue and work and improve, but it's not going to break things. So that's a big thing about Fortran is backwards compatibility. Now, another thing that didn't that Fortran 90 has over Fortran 77 was the fact that it Fortran 77 didn't have any sort of recursion. Fortran 90 does. That was introduced in Fortran 90. Now, I also want to bring up this one. Now, I actually rewrote this. So this is word count from Word. As you can see, there are just a bunch of A's. I'll show you the text document that I'm going to be using this program on. Where'd it go? There it is. Right. So it's just 1.2 million A's. Okay, that's all it is. Right. 1.2 million A's. Now, I am going to show you. Let's see. Where's my other folder here? I'm going to show you a program I've been working on. This is actually, I'm sure, I think I sent one of these to someone. I think it was Joey. I think I'd sent this to you, Joey.
Oh man.
I rewrote it because it was pretty ugly. Now, I use some more modern things. I kind of, like I said, when I started learning Fortran, it was aimed towards the TI-99. So I kind of focused more on Fortran 77. So that's the other version was written mostly in Fortran 77, but kind of not. Kind of a problem with Fortran is that if you're not careful with good practices and using the right standards, you'll have kind of a mishmash of different standards. So I just kind of updated it and made it work. Now, this program takes in a file containing text data, alphanumeric and non-alphanumeric characters, and counts the occurrences for each. It will then print the results to the terminal and output the results to a file for later use or storage. So it contains the following routines. Init counts, and it initializes the environment for processing. Opens the file, reads it in, and calls the next routine. Init arrays, initialize the arrays used to check against, and arrays used to store counts. The count is set to 0 initially to make sure it is in a known state. There's a reason why I did this, and it was because it was like I had like 900 million O's for some reason, and it was because it just kind of decided that there were 900 million O's where it was. It was probably something that a different program put in that memory location. Count letters, it actually counts each letter. Print counts, it does the things with the printing. Now, one of the big things that drew me to Fortran 90 was the fact that I can use this guy, allocatable arrays. Now, the cool thing about this is that it can change size and shape during execution, not at runtime, but during execution. And that is an extremely handy thing to have when you're doing stuff like reading in an unknown amount of text, which is exactly what this program does. So I'm going to show you that different one. Let's see. Copy. Okay. Now,
Beautiful. Oh, it ran in 0 time. It's so fast. Also, yeah, nice.
did the wrong thing, but that's okay. This is what it counted, by the way. This isn't what I wanted it to count, but that's fine. Oh, it's because I moved it to the wrong dang folder.
The struggle is real.
Right. It took a little longer.
There we go.
Yeah, so it does count it, right? It does do the business. It took 230 milliseconds. 203 milliseconds, I'm sorry.
Nice.
Now, it will also save that in results.txt, right? So right here. So what I plan on doing with this is actually making something called it's a lexical analysis tool for like, you know, various reasons, but I haven't started on that yet, but let's see. This is one I just kind of threw together for you guys to see. This is an actual use case for the thing I just threw away. All right, so basically, here it is. So, okay. So, I created using that exact program, except I changed it to a module. Right. So remember what I said about modules earlier. They're like the packages things, just they're compiled but not. So basically, when it says use count occurrences, it means use this. This, I created a. Does anyone here know what a shift cipher is?
Oh, actually, yes, I do.
Okay. Well, James, why don't you share with the class?
Well, in my limited understanding, it takes a certain set of characters or letters and it matches them to another row, except another row of the same characters or letters, except it shifts it over by a certain number. So one character maps to another character, and so on down the line until the full set of characters is remapped.
It sounds like the Little Orphan Annie cipher ring.
Yeah, that's exactly right. That's exactly right. That's called a shift cipher.
Nice.
Now, what this does is it takes a cipher text, which is right here. Let me pull this out. So it's going to take this cipher text, right, which looks like gibberish to us, and it's going to count the letters using this, right? It uses the count occurrences program I showed you earlier. It calls initialization from count occurrences, and then it calls, after all this, it calls try shift. So an integer n, which is just an index here, so n from 0 to 100. So that means, in this case, this would be a shift of 0 to 100. So basically, it's going to shift it so many times, right? So it's going to shift it 1, 2, 3, 4, 5, et cetera, times. And then I have it from negative 26 to 26. Forget why I did that. But it works. That's what matters. Then it goes through the letters. I think it's the lowercase. That's right. Yeah, lowercase. So this just basically does the thing. So this is how they do loops in Fortran. So do from here to there and do. If and if. Are you guys noticing a program with the ends? Instead of like brackets, they use block. So if, then, and if.
Yeah.
Do and do. Right?
I think
Subroutine and subroutine.
I think SQL has stuff similar where it has like begin, end.
I think so. So does COBOL. Right. So I will show you. I already ran this on this. I'll just show you the output. I think that's a little bit more interesting than watch it just kind of flash on the screen. So this is what the program actually puts out. So nothing interesting, nothing interesting, nothing interesting, nothing interesting. So as you can see, this is a brute force way to do this. And where did it go? Somewhere here. This is not the best way to do this, if you haven't noticed. Here we go. The Caesar cipher can easily be broken even in a ciphertext only scenario. Two situations can be considered. So that would be the plain text. It just took, I don't know, 100 times and I don't know, probably 100 lines of code to break it. So basically, that's Fortran. Are there any questions? I mean, I kind of want to take a little bit more questions than I spent boring you guys with looking at code that you guys have little experience with, right? Anyone?
What other
So-
things? Oh, go ahead.
I guess I was gonna say, so Fortran's, it's supposed to be fast. I guess sometimes, in C or, well, I guess especially assembly, I have a very easy time seeing the machine code that goes with the instructions. With Fortran, it seems like a bit of a higher level language, and so it kind of surprises me that even though it's higher level, that it, you know, in those kind of languages, you should be able to see the assembly that kind of builds it. I guess I have a hard time seeing it, which kind of surprised me.
Interesting observation. Part of that is because I'm using it as a high level language. I'm not using any of the real low level constructs. You know, there are a lot of low level stuff in there, and that's one of the biggest things that motivated Fortran was that. Well, I should say the reason why it was so widespread was because the performance dip between assembly and Fortran was low enough for people to really see the benefit of using Fortran for scientific computing. That was one of the biggest reasons why it's still been around. Actually, is because it's not like COBOL where people know COBOL because they have to because everything's written in COBOL. It's not like anything like that. Part of it is, but for the majority of COBOL, it's a dead language. Fortran is not. It's a little old. It's dated, but it's fast as, if not faster than C.
What does it compile? Does Fortran compile directly into assembly?
Yes,
Okay.
not assembly, but machine code.
Oh, it goes from really? So it goes from Fortran to machine code?
Yep.
Oh. So I guess that's weird. I didn't expect that. I guess that's one of the reasons why it's so fast then.
Yeah, it was basically a replacement for assembly.
Okay.
Any other questions?
Nope.
You said it was for NASA. Like, what do you mean? Like, what for?
Well, a lot of well, to be fair, I didn't say that,
I said that.
but yeah,
Yeah.
yeah, the I think it was Apollo 11. A lot of the routines for that, the computer on there, were written in Fortran.
Interesting.
Yeah, my understanding from what I've heard from other people in our major is that um, it's just a language that NASA used throughout the years because their business has to do a lot with numbers and often has to do things with also has to do with doing things quickly, and so it was a good language for that. And I don't know if in some places I imagine they're trying to upgrade, um, for lack of a better term, I guess, and just I don't know, do like just change it over to different languages, but it is
They've been
still.
trying to do that for years.
Yeah, but it's like so widely used that like if you come to work for NASA, depending on your department, if it's a department that utilized it heavy, then it's something you got to know and program with.
Well, another thing is though is that it's still probably the best language for arrays. Uh, the the way that it uses arrays is probably the most important data structure in the language,
Mm-hmm.
and the way that it handles them is very fast. Uh, Certainly better than Java.
Yeah.
uh, the thing is that with all of that, it is still used because it is a fast language. And it's not exactly something that you can just say, oh, this is a fast language, this is a slow language. There's a lot of nuance to that. I really can't think of any reason why to learn Fortran for like web development. That sounds terrible. But if it's possible, you can do it with Fortran. But you never know how good it's going to be.
Gotta know the proper tool to use at the proper time.
Yeah,
Okay.
exactly.
Are there any other questions?
Have you tried OpenMP and Fortran together?
I haven't yet, but it is actually a part of Fortran 2008.
Oh, it's like just a straight part of it.
Yeah.
What's OpenMP?
It's a way of doing multi-threading.
Oh.
I think it's message passing is what it is.
Yeah,
MP stands for message passing.
Yeah, it's confusing because there's also MPI, which is like the message passing interface, which you can also use. But the main stuff with OpenMP is it can do like your for loops and stuff. If it's just looping over an array and you can just do them all at the same time, you can add like one command and it just multi-threads that workload itself.
And
really?
Yeah, with Fortran, it has the do concurrent.
Oh yeah.
So yeah, it also has co-arrays, which are basically arrays that are images of one another that exist in a shared memory space that each processor has access to.
That makes sense. That's pretty cool.
Yeah, that's what actually was originally called co-array Fortran, which eventually became 2008. I think it is a pretty nifty language. There's a lot of neat things with it. I also found the Fortran compiler that I'm using has some things that I can write scripts with.
Oh, really?
Yeah. I mean, it's not like going to be like in a you know, an interactive environment like Python or an interpretive language like that. But I can write and automate things because it's got like, you know, I can write to the console, get commands from the console, stuff like that, just using one procedure. So, for instance, it would be like call uh, call execute CMD argument, I think it is, and then you put in parentheses what you want.
Okay.
So it's pretty nifty.
Yeah.
But yeah.
All right. Well, if there are no other questions, I like it because it's kind of cool. It's kind of cool to see the progress of a language that started out with punch cards and eventually worked its way to being an object-oriented language. That's
Oh yeah.
That's kind of nifty.
Speaking of, I forgot to show you this. I searched forever to find a picture of this, but this is an original Fortran program.
Nice.
Yeah.
Don't draw.
Don't draw.
No kidding. But incidentally, that's what this identification number is for too.
So you can put it back together when you drop it.
Well, the computer would, the card reader would.
Yeah, they had. Isn't that one of the bucket sort or something? Is specifically made for like sorting punch cards?
That's right. There's a punch card sorter. I forgot about that.
And there's an algorithm that goes with it because it doesn't sort them just like going through it.
That's beautiful.
Now this is the actual key punch.
Beautiful.
Yeah.
IBM's baby.
And yeah, just to be clear, this was another invention of IBM. And you know, Fortran is extremely influential. You know, I mean, it really did bring computer scientists away from just assembly language, because it was one of the first, if not the first, to show that the performance was comparable to assembly language programs if done correctly.
Would you say that it paved the way for C?
In a way, yes, but C is more closely related to Algol.
Oh, that's another language?
Algol? Yeah.
Okay, I haven't heard of it before.
Let's see. It was, yeah. So it influenced PLI, Simula, BCPL, B, Pascal, and C.
Okay.
Which would be the Algol-like languages.
Got it.
And it was a contemporary of Fortran.
Okay. I've never heard of this one. Not that I remember.
So yeah, I guess it did influence C, according to this. Interesting. The more you know.
All right. Well, sounds good. Thank you very much, Kyle.
Absolutely. And if anyone has any more questions, don't hesitate to ask. I'm always bored. Oh, yes, the links. I forgot to add the links.
Okay.
I'll be putting these in chat right now.
Sounds good. And I will get this recording up as on the ACM YouTube channel as soon as it's done uploading.
Okay.
All right. Sounds
good. The first one is the Fortran Wiki, which is a very good resource for Fortran. The second one is actually how to get the Fortran compiler, the GNU Fortran compiler for Windows and Linux.
Okay.
Genie is my preferred IDE for Windows when I'm doing Fortran. It's pretty light, pretty nifty. And then that bottom link is that document I showed earlier with the reference book for the first release of Fortran.
And you were using the Windows subsystem for Linux to run. That's what you were running all of your programs in.
Yes, I was indeed using that. just installed LXDE on top of it.
Okay. I think you can just. Do you just go to the Windows Store and you can like?
Yep.
Okay.
But you can enable it.
That's right. Yeah, I had to do that.
If you already have it, yeah. Then you just open up your dude and download LXDE. But you also need the VCX server. You got to do a little configuring. It's not too bad. It's actually like a 10-minute process.
Oh, okay, that's
And
not bad.
loaded and installed. It works great. The only thing is there are some problems. It's obvious that you're not running a full distro. You know what I mean?
Okay.
It's not quite as it's kind of almost like an emulator.
Oh, really? Okay.
With the desktop part. There's definitely some glitches and stuff like that, but for the most part, it's pretty good. It's nice and stable.
Okay.
I leave it open all the time, so I mean it hasn't crashed.
Nice. I like the idea better than dual booting.
Yeah, me too. Yeah, I just leave it open and then I just stick around with my Linux distro. I mean, it's the same computer, it's the same operating system, so that's really nice.
Right. All right. I'm
But-
gonna stop the recording.